All right. So, using Newton's second law, what do we know about these relationships here? What do we know about CB and FG? They're equal because the physics book is not moving, not just moving, but not at max center. Good. So we know that FCP equals FG, and that's in magnitude, not direction.
Yeah.
Right? What about here? What's the case? So FTC equals FPC plus FG. So the force on the chemistry book from the table equals the force on the chemistry book from the physics book and the force of gravity, right?
Yeah.
Okay. What about down here? What do we know?
Fn equals FCT plus FG.
Okay. So the normal force
CC.
exerted from the ground on the table equals the force of gravity acting on the table plus the force of the chemistry book on the table. Does that make sense? So remember these like CPs. This is force of the chemistry book on the physics book, force of the physics book on the chemistry book, force of the table on the chemistry book, force of the chemistry book on the table. Right? Does that make sense, guys?
Yeah.
Now the last thing I had to do on Friday was to identify the third law of pairs. Okay? So which forces are equal and opposite? Okay. The ones that have an F before them, Rex, that is way too vague and that is not correct. So, which forces are equal and opposites?
FCP and
Okay. FCP and
FPC.
FPC? Okay. So these two are equal and opposite. Because if you remember from the drawing, Reggie, pay attention. We have the chemistry book on bottom and the physics book on top, right? So the physics book pushes down on the chemistry book pushes up with the same force, right? Does that make sense?
Yeah.
So those two are equal.
FTC and FCT.
FTC and FCT. Those two are equal, right? Because that's the chemistry book pushing down on the table and the table pushing up on the chemistry book. Okay, does that make sense?
Yeah.
Okay. Now, the physics book has a mass of 2.5 kilograms. The chemistry book has a mass of 1.8 kilograms because it contains less knowledge. Okay. Small little jab. All right. So, I want to know the normal forces exerted on the books. Okay. I want to know the normal forces exerted on the books. So, A, what are the normal forces exerted on the books? Okay. Well, which of these are normal forces? Anthony, which one's a normal force? For either book. Tell me one normal force. You got two options. Should have been sleeping, huh?
No.
Yeah, okay. So, which
You
one's...
still got it.
You got it? Which one? Okay, remember a normal force is perpendicular to a surface, right? So which way is it going to point, up or down? Up. So you could have said either of these upward forces.
I know where you're at.
Okay. So this right here, this is a normal force because it's from the chemistry book on the physics book, correct? Right?
Yeah.
So this is one of the normal forces. What's the other one?
Table. FTC.
FTC, the table on the chemistry book. So those are our two normal forces. So I want you to find those two forces. Okay? Now, what we did with Newton's second law and what we did with Newton's third law is going to be very helpful. Okay? Which one should we start with, the physics book or the chemistry book? The physics. Why the physics book, Omar?
Because it's the class we're in.
Okay? Because it's on top and it's has a lot easier equation, doesn't it? Okay? If I make a list of the things I know and the things I don't know, the physics book will have one unknown, where this chemistry book equation will have two. Okay? Because I don't know the force of the physics book on the chemistry book yet. Okay? So let's start with the physics book. Okay? So what things do we know?
Gravity.
Gravity. Acceleration or force?
Acceleration.
Acceleration. G is
9.8.
meters per second squared. And we do know the force.
We know that physics is better than chemistry.
We do know that. Thank you. Trying to get an A, aren't you?
Yes.
Oh, you better watch your mouth. Okay. So, G equals 9.8 meters per second. Force of gravity equals mg. Right? Does that make sense?
Yes.
Okay. What else do we know? Jameer, something else I know. This is the physics book, right?
The mass.
Okay, the scholars trying to help you out. We know the The mass. What's the mass?
The weight.
2.5 kilograms. It is not the weight, Skylar. Okay, the weight is the force of gravity. Mass and weight are not the same. Okay. Anything else we know, or do we have enough information?
We know.
Okay, good. Because for the physics book, we know the force of the physics book, or sorry, the force of the chemistry book on the physics book equals the force of gravity on the physics book, correct?
Can you redraw this?
Better?
Yeah.
Okay. Guys, does that make sense?
Yeah.
Reg, you're giving me kind of an interesting look. Does that make sense? Okay, this force of gravity, is this on the physics book, the chemistry book, or both?
24.5.
It's only on the physics book, right? It's only on the physics book, okay? So FCP equals the mass of the physics book, 2.5, times 9.8. What does that equal? Thanks, Rex. Okay.
I'm always here for you.
Guys, we're going to go to the bell because you guys want to keep talking about other things, okay? So keep your stuff out. So 2.5 times 9.8, what is that?
24.5.
24.5.
24.5.
Newtons. Right? Does that make sense?
Yeah.
Okay. Now, let's look at the chemistry book. Okay. For the chemistry book, what do we know?
The mass.
The mass. What's the mass, Skylar?
1.8 kilograms.
1.8 kilograms.
It's not the weight.
Does it the weight the same?
Good. No, it's not the same as weight.
No, I said it doesn't have the same mass as the physics book.
It does not.
Why
No,
not?
Because physics books have more knowledge. Okay. So, the mass is 1.8 kilograms. Right?
Yeah.
Okay. What else do we know?
Gravity.
Gravity. Acceleration is
9.8 meters per second.
9.8 meters per second squared. And we know the force of gravity equals mg, right?
Yeah.
Is there anything else we know from the chemistry equation?
The force of PC.
Good. We know that PC and CP were Newton's third law pair, right?
They're
Yeah.
equal.
So that means these two are
24.5 newtons.
equal.
And opposite.
So since the force of the chemistry book on the physics book was 24.5, the force of the physics book on the chemistry book has to be
24.5.
24.5. Okay. So then using our Newton's second law equation,
I don't like this.
we know the force in the table is going to be equal to,
24.5 plus 1.8 times 1.8.
guys, stop standing up and pack it up. Okay? So 24.5 plus 1.8 times 9.8, what does that equal? Guys, you have calculators.
Hold on. Oh my gosh, this just made my day. It says have a good day.
Nice.
Equals 42.14.
42.14. Okay. Thank you. Okay, so that is the force exerted by the chemistry book on the physics book. Okay? Does that make sense?
Yes, sir.
Okay, now, one more thing. Guys, I'm not done yet. Take a seat.
I'm going back.
No, take a seat. Sit in your seat. Okay. Guys,
We don't know the mass of the table.
last one on the table. Now, part B on the prezi slides to the table. Have a good day, everybody.
I thought you were going to say you can teach.